The following video presentation was created for a virtual conference on connections, exploring heritage, architecture, cities, art, and media, 29th and 30th of June 2020, sponsored by AMPS and hosted by the University of Kent and the Kent School of Architecture and Planning, Canterbury, UK. I am Dr. Woodrow Hood, Director of Film and Media and Professor of Communication at Wake Forest University in Winston-Salem, North Carolina, USA. The application of machine learning in music composition has really almost become commonplace in the creation of media soundtracks today. AI music and generative composition technologies promise to offer new technologies to improve the creative workflow of sound designers and music producers by diversifying approaches to composition and design. Though true artificial intelligence does not currently exist, we nevertheless use the phrase ubiquitously in popular culture. Tom Mitchell in AI Magazine once said this, quote, "Ever since computers were invented, it has been natural to wonder whether they might be made to learn. Imagine computers learning from medical records to discover emerging trends in the spread and treatment of new diseases. Detailed understanding of information processing algorithms for machine learning might lead to a better understanding of human learning abilities and disabilities as well." We're going to take a look at two different pathways for composing soundtracks for media. One is machine learning, and the second will be generative audio. These two approaches are not rigidly exclusionary, but they actually work exceedingly well together, though they can also be utilized independently in any given process. In that earlier quote, Mitchell is talking about machine learning, which can take large sets of data, in my case sound or MIDI notes, and can quickly determine patterns. The sound and music artist can take these patterns as new elements in a composition, arrangement, in the mixing, or the mastering process. Generative audio has less to do with crunching data sets. Generative audio uses a system or a process to create sound or music through a series of guidelines, rules that the machines follow that are set by the artist. I like this quote from the video by Loop Pop on YouTube, "Always different and changing sound or music generated by a system, but led by creative guidelines rather than music that follows predetermined notes." I will let the masters of generative audio and video, Will Wright and Brian Eno, explain.
These are cellular automata, which probably a lot of you are familiar with. And the idea behind these is that they're very simple rule systems. And we run the rule, and it actually analyzes every cell in here. Each one of these cells looks at its neighbors, analyzes what's around it to determine its new state. And so it's the same rule applied to every cell, but because the number of neighbors is different, you get different patterns emerging. So I'm stepping through this very slowly. But
we should perhaps give the audience some idea of what these rules are like. They say things like, if
let me load Conway.
If three of your neighbors are alive, you're going to die, or you're going to survive in the next generation. If you've got only one neighbor alive, you'll die. If you have two neighbors alive, you'll persist, whatever.
And that's the exact rule set that
those kinds of rules.
Perhaps to oversimplify, the artist creates the rules and the machine makes the art. Let's take a look at a couple of examples to clarify my meaning. There are many machine learning projects and companies that are developing softwares that artists can use. One of these is the Google Magenta project. MuseNet has been built on Google Magenta, and it's a deep neural network that can generate 4-minute musical compositions with 10 different instruments and can combine styles from country to Mozart to the Beatles. Let's take a look at one of these examples. In the following video, you're going to see Lady Gaga's Poker Face being reconstructed by machines and rebuilt as country music, using data points from lots of country music songs and the MIDI data from Lady Gaga's song. What you see the MuseNet machine doing is actually creating a whole new work of art out of what currently exists. I have taken these new MIDI notes, this new song, and I have reproduced it as this. A more detailed example can be found in the Los Angeles band Yacht's last album, Chain Tripping. The group worked with Google Magenta to analyze their entire back catalog using machine learning. They took that data and found melodies between melodies that were used as the source material for the new album. No creative jamming or traditional process composition allowed. The results were a Yacht album, having the hallmarks of the band and consistent with their style. Claire L. Evans of Yacht explained at a Google conference.
This is basically what we used to make our record. We experimented with a bunch of different strategies, but we found that the best compositional tool for us was Magenta's music VAE model, which is a latent space interpolation model that allowed us to find, essentially I know this isn't the technical way of explaining it, but it allowed us to find melodies hidden in between songs from our own back catalog. And this is what the user-facing side of that model looked like when we were initially recording the record. When we had this massive amount of musical information, that's when the human being process began. This is when we started manually culling through all of this MIDI data, trying to find interesting moments, things that spoke to us, things that felt interesting, things that we wanted to explore further.
Here, Claire Evans is laying out the collaborative process between machine and human. What for them are the human parts and what for her are the machine parts. Let's play a little game. We're going to listen to several songs and we're going to try to determine which of these have actually been created by machines and what is an original composition in the old style of music composition. So which was it? The hip-hop piece, the two pop pieces, or the Irish folk music? Well, it's a trick. All of these pieces were composed with machine learning and artificial intelligences. For an example of generative audio, the next video shows a modular synthesizer and a piece that I composed in my studio. The modular synthesizer has been programmed to play a composition, and you will hear me moving and changing and adjusting that composition in real time. I once heard somebody draw an analogy between playing modules in a module synthesizer and the band leader conducting a band. Generative audio and machine learning can not only be helpful in the composition and recording process, but it can also help in the mixing and mastering part of the process. Next, you'll see a video from my digital audio workstation, FL Studio, where I've taken the information, the track from MuseNet, the Lady Gaga country remix, and I'm using machine learning to run a process in which it is mastered and mixed. As an old professor of mine once warned me, so what? Who cares? The opportunity here seems to suggest that the artistic function may have now moved. A choice now exists. We may no longer require a master creator who composes music and sound by writing out notes and chords and arrangement, but to a nexus of artist and machine working in handshaking tandem. The computer generates ideas and the artist selects or deletes those options, resulting in a new work. This new work is part human and part machine, a cyborg, an augmented posthuman soundtrack. The result of the change in process nudges the compositions away from a reliance on theme, leitmotif, and highlights a mix of noise, sound, and alternate and diverse modes of music composition. The means affects the outcome. Alongside traditional musical instruments, keys, strings, brass, percussion, composers are now using tablets that read hand gestures, softwares that generate notes, pushpad controllers, analog strips, and even cameras that record movement and turn them into notes or chords. Traditional music training is a bonus and a goal, but perhaps not required. I have no interest in projecting a robot holocaust. I'll leave that to James Cameron. Nor am I interested in embracing new technologies without understanding the implications of the change. My project here is to note a shift in the way we work as creative and collaborative artists and what it means to use these new tools as part of our process. This shift has been happening slowly for decades, but it is also building up with some speed. Artists are always interested in infinite flexibility and choice in the creation process. As you've seen in the examples, the machines can shoot out many different ideas, but it's the human that makes the decision to include or exclude those ideas. Whether it's in composition or in mixing and mastering, our real value of humans in the process are our ears and brains. We hear things we like and make choices. What you see on the slide before you are suggestions about what may be the steps in a creative process. Now, we can argue that some should be put together, maybe deleted, maybe I've missed a few. But what I'm suggesting here and noting as I work with machine learning and generative audio is that the process of selection has much greater emphasis and has become much more important in creating than maybe ever before. Part of the selection process now is actually choosing what creative process that you're going to use, whether to use traditional composition, arrangement, mixing, and mastering, or if you're going to use the computer as a collaborator in that process. I'm not a band member of Yacht. I don't need to make a Yacht-style album. As a matter of fact, I don't need to be consistent with any type of musical or audio style. I need to be diverse. Machine learning and generative audio allow me to gain that diversity when I'm working with video and film, where traditional approaches may limit my scope. I want to thank AMPS and the University of Kent for putting this conference together, and I look forward to further engagement. Thank you for listening.